Hi, dear students. You know quite well if the object to create this model is an assembly, in the memory of the computer, first we should have a folder to keep the data in that address, not the files created by the user only, but also the ones created by the software. While we are assembling the components, invoking the models of standard objects from the library of the software Inventor, well, Inventor creates lots of files to keep the data at the background, and these are saved at different addresses in partition C. To be able to gather all the files and have packaged them within the same address, well, there is a process to apply. Inventor names that facility, clicking on the option, that process is started, saying pack and go. To be able to take a right to apply packaging process via which to gather all the data within the indicated address, and also, well, at the file saving and stage, and also opening an existing file stage. To be able to save time and effort, the thing to do is that define the work as a project. There's a procedure in Inventor. In a few seconds, maximum 1 minute, it's possible to teach the software that the work is a project. Yes, you know this from the learning outcome of Mac 114. It is, one of the chapters in the content, assembly modeling. Here in this design course, it is, for educating the students, on the calculation tools of software Autodesk Inventor Professional. Be aware, while we are defining the boundary conditions in the environment and then discretizing the object into sub-portions, finite elements, and then, running the software to calculate the output, the results, stress, strain distribution, for instance. While we are dealing with such things, Inventor at the background creates a folder, and within that folder saves and keeps the results of the calculations. If by mistake only send the model file for the interest of the other, not the associated folder that is created by the software automatically, in which Inventor keeps the results of the calculation, then the other person can open the solid model file but cannot see the results of the calculation. So, to be able to take a right to apply pack and go process, and also to enable the others to see the results of the calculation, it is the thing to do. Strongly recommended thing. Create a folder, okay? Show that address as the project folder. Of course, in doing this, define the work as a project, and sure that the model on which you're going to make the necessary analysis, design analysis, calculation, stress analysis, etc. Well, have the solid model of the object in the same address within that folder. Then Inventor, while we are using the calculation tools, well, creates at the background a folder where in the address Inventor finds the solid model over there, and within that automatically created folder keeps the results of the calculations. So, okay then. In this example, yes, step by step, pass through such stages. But in this example, the object won't be an assembly, one of the components of an assembly, let's say. Well, my main purpose to say, well, would it have all the things within the same folder? Okay, it is important, and if there will be a calculation part, okay, for the corresponding model, then well, sure that it is necessary to send not only the solid model file but also the associated folder well created by the software, and where software keeps the results of the calculations. Okay then. Create the folder in the memory of the computer. It is the folder for that work, for that project. Name the folder, well, considering the content of the folder. For instance, if it is a folder where the model of, for instance, a shaft assembly, and also the necessary design calculations are to be kept, then name the folder saying shaft assembly. Here I'm going to save the folder to say that it is the folder just issued by that person. Gonna write the surname, my surname, and then, well, in school, well, I say that request my dear students to write the ID number, and then say that it is just a classwork. Let me say double classwork, CWE. It is the first classwork. On which day? On such a day. Well, say for instance, well, it is one of the days of March. Okay, say that for instance, the first day of March. Okay. Within, this is the project work folder. Within the folder open, well, to be able to show the destination address at the stage to gather all the files while applying pack and go process, going to create one more folder as nested. Say that surname, ID number, okay, for classwork 1, that is the package folder. And date of packaging is the first day of March, March 1. It is like a barcode. Looking at the name, can say that it is the folder or work studied by that person. It is a classwork requirement, and it is for the packaging. It is the folder for gathering all the files created by the users and created by the software. Now, within this address, since the model creation is not so difficult, I'm going to um, directly um, transfer one of the solid models already created, okay, into this address. Since the solid model is now within this folder, when the calculation tools of the software are used, Inventor will create the log folder, the folder in which Inventor keeps the log files, the results of the calculations within this main folder. Okay, now define the work as a project. Now, at this stage, close all the files in Inventor you want, ensure that to be able to define a work as a new project, sure that from the list, the selected option is default. Default option highlights that, yeah, I selected default option. Default, if the selected option from the listed ones are except default, the others, the names of the projects, this means there is no active project at present. There shouldn't be any active project. There shouldn't be any active file within Inventor environment to be able to define the work as a project. For defining the work as a project, bring the cursor onto File tab along the tab menu bar, and then after the click, find in the list Manage option. Don't click, and move the cursor to this pane, and over there it is written at the top Projects. Yes, to define the work as a project, click on Projects option from the list, and then yes, this dialog box will appear. For defining a new project, yes, as it is implied with the word on this tab, clicked on this tab. This click will bring this sub dialog box. For schoolworks, yes, no, most of the cases the work is to be single student work, single user work. So new single user project. And then clicked on next button. And then in the dialog box, next dialog, write the name. The name of the project. It should be meaningful name. Thanks to the name of the project, then someone can easily say something. In that project, which one is issued or to be studied, or it is about which work. If it is, for instance, aircraft design project, then say aircraft. If it is automobile project, automobile. But in school, I request my dear students, to write in naming for a folder or a file or a project. I say that write your surname, ID number, and then, if it is a classwork, then CWB. If it is homework, say HWB. If it is exam requirement, say depending on the exam, quiz or pub quiz or midterm or final. Okay, then write the project name accordingly, surname, ID number, and this is just one of the classworks in the content of the semester. Write the classwork number for that day. Date is March 1, first day of March, let's say. And then in this dialog box, show the project folder. Well, I know where it is. Already created a special folder in the memory, and I know that it is the project folder. So clicked on this button on which there are three dots, triple dot. It is to show the address of the project folder. Well, after clicking on this triple dot, well, another window appears, and well, the listed ones are in the structure of my computer, the folders. Okay, my computer, this PC, clicked on the associated arrow, and I know that I created the project folder within this subfolder, within this partition, and which folder? This folder within this subfolder, and that is the address for that work, for that project. Already created, indicated, and then say OK. Yes, that is the name of the project, and that is the address to have all the things, okay, for that project. That is it. Making such things, and finally clicking on finish button, sure that we notified the software that this work is a project, and that is the project definition stage. Clicked on done. Okay, well, thanks to passing through such a stage, repeat again. Well, Inventor automatically finds that address at the file saving stage without asking the user. When I say open a file, well, in the content of that work, then Inventor automatically drops the list of the files, those have been saved within the project folder. Well, if it is so obvious, that can which save time and effort. But the main value of the project definition is that, well, thanks to such a definition, pack and go process will be applicable. Okay. Well, for design calculations, I said that, okay, why not? Since it is a work, and say that have all the files created by the user and also created by the software within the same folder, within the same address. Okay, use that folder for having the results of the calculations in a nested folder. That folder is created by the software. For instance, at present, within the project folder, I have, package folder. It is empty, completely empty, because pack and go process has not been applied. I didn't apply the process yet. Within the project folder, I have the solid model of the object. For that object, I'm going to perform the design calculations to check whether, under the action of the applied forces by the surroundings of that object, whether the material will yield or reach to the strength limit, or there will be a failure, fracture. Well, in this example, in this classwork, say that object is to be truly in elastic region. There shouldn't be any plastic deformations. Okay, so if I see that yield limit, the stress value at a certain point is equal to the yield limit, or greater than the yield limit. If it is less than the yield limit, then the basic stress analysis tool of Inventor can be used. But if it is seen that the stress value, at least at a point, is greater than the yield limit, then need to use either Fusion to solve or to deal with such a design problem, or Inventor Nasra. This classwork said that well, the material will be or is to be in elastic region. Yielding is not allowed. Okay, but here, well, I have this solid model file. Yeah, here it is, the content of the file. But there is no folder yet created by the software, okay, as associated with the design calculation. After performing the design calculation, I'm going to reopen this folder, and you're going to see that there is one more folder, okay, created by the software. When you open that folder, you're going to see the log files in which Inventor keeps the calculation results. Okay. Yes. Open that file. Click on Open an existing file button, and you see Inventor, without asking me for the address, automatically drop the list of the things within the project folder. Inventor knows that the work is a project and automatically selects the project folder at the file opening stage or file saving stage. Okay, I'm going to open this file, and then for this object perform the analysis, just to check, it is to check whether the object under the action of the applied forces going to be in elastic region, so well, it can be safely used. Well, already assigned the material for this object. It is made of aluminum 6061 alloy. Well, I have contour bore holes here and there. Well, after sliding the object along the slot, well, this prismatic extension, where it is at the bottom side, well, will be a guide for the object along the channel. Where is the channel? Channel is an entity in the design of the other component. Okay, after sliding this bracket to the correct position, then we'll insert the standard bolt through this hole, through that hole, and then, well, at the other side, what we have, the complementary component nut. Okay, tightly screw the bolt into the nut, so we'll have a fixed connection, well, over the surface of the contour bore. Well, there will be a force system applied, distributed force applied by the head of the bolt. Okay, so I'm going to say as boundary condition here and there, object fixedly connected. Okay, and in the example, say that this is the hole to house the shaft. Shaft to it is one of the shoulders. Apply a force in the axial direction. Okay, onto this this bearing. Okay. Yes. Now the boundary conditions. Clicked on environment step, and then if the problem is the one well, the material will be in elastic region, and well, the temperature of the body is uniform, there is no heat transfer, then yes, can use this facility, basic stress analysis tool of the software. Otherwise, I would say that clicked on this button, use Nasra. Okay, now here assume that this object will be in equilibrium to its surrounding, energy equilibrium, thermal equilibrium, and the temperature companies can use this facility. Using this tool is easier, but well, it is conditional, you know. Clicked on this. After the click, then well, there will be analysis tab to its ribbon. Okay, and then well, clicked on create study button, and in the dialog box, well, whether teach the software via selecting the radio buttons, you're going to find the stress distribution. Object is to be under static conditions, or resonance frequencies, natural frequencies. If you're going to use this calculation tool for determining the resonance frequencies, select model analysis radio button. If you're going to modify the shape and via which if it is possible to save material to decrease the inertia of the body, select shape generator option. But in this example, my purpose is to find the stress distribution. So select static analysis option and then clicked on OK button. And then along the ribbon, accept results and display tools, all of the others will be active. After solving the problem, then results and display panels will be active to their associated facilities. Okay, if the material has not been assigned, then clicked on this button and assign the material. Boundary conditions. Clicked on this button and then say that this surface we have a force system, and here and there object fixedly connected. Okay. Onto this surface, a pushing force is applied by the shoulder of the shaft. Okay, clicked on this button, and then the magnitude of that force is in this example, say that 1000 Newton. 1000 meters. Write it into this box. Okay, it is in which direction? Indicate the surface and then check. A yellowish arrow will appear. It is just to say that force is being applied. Forces are being applied in this sense. To where? Over the indicated surface. Although there is only one arrow, be aware it is to see the sense of the applied forces. It is a representative vector. This does not mean that there is only one force, point force, that is applied onto the surface. No, the force distribution is uniform over this annular surface. If the surface is an oblique surface or inclined, then select this box with a click and then write X, Y, Z components, Cartesian components of the oblique force system. Okay. Sense is correct. If it were wrong, then clicked on this one and reverse the direction. Force is not pushing but pulling force, then I will flip-flop the direction. Okay, then that is one of the boundary conditions. Okay. The force applied onto the surface of the counter bore by the bolt against the nut. Okay, again, distributed force. Say that over the surface we have 500 newtons. Okay, apply. And over the other surface, say that it is the same, apply. Assume that the object is to be used under the action of such forces. Of course, when we solve the problem, especially here and there will be reaction forces. Okay, but the reaction forces are calculated by the software. Okay, Inventor uses finite element method, numerical analysis. Solving this problem, since it is just an introductory record or class work or lecture, I'm going to use the default mesh size. Following lectures and the corresponding video records, I'm going to say that, okay, there is a sharp directional changing. Okay, to be able to decrease the stress value in the vicinity of sharp changing, use rounds, fillets, and also to be able to find the stress value more accurately if the geometry is not uniform but it is changing. Such places use a smaller sized finite elements to be able to increase the accuracy of the calculation. But here, I'm going to use the default configuration of the software, and also enable the software using its default setting to use mesh size as greater if the geometry is not changing the same, otherwise smaller mesh size. Not manually but automatically. The mesh size going to be determined by the software. But the next class meeting, I'm going to educate under the control of the user how the mesh size is changed, and especially how a finer mesh is used at the places where the geometry abruptly changes. Okay, see the default mesh, clicking on this button. Yes, Inventor divided the object into sub-portions. You see, I didn't say anything, but Inventor here saying that geometry abruptly change, decrease the mesh size. But couldn't do the same thing along this sharp edge, along that sharp edge. Okay. And then, clicked on Run button. By the way, the body force, okay, weight of the object. Relative to the applied forces, if the weight is not negligible, then define the earth is which side. Clicked on gravity button, and then, indicate the surface, this, or bottom side surface, and then check the representative yellowish arrow is in which sense. Inventor indicating directed the representative force in the down direction. Here say that it is true. The earth is at that side. Okay. So it is applying such a gravity force. The gravity force is in this direction. And assume that the object is at the sea level and the gravitational acceleration at such a level, 9.81 meter per second square. Okay. And then yes, clicked on simulate button. If everything is okay, then without an error message, receiving error message, can see the result of the problem. clicked on run button, and then follow this progressing. Yes, and then yes, Inventor completed the solution, and along the scale, see that, well, if the color is blue, then well, this means stress is very small. If it is cyan, it is in such an order. If it is red, then it is the maximum. For the maximum, for the points where the stress is maximum, well, Inventor use red color. An inventor represents, calculates in its default configuration von Mises stresses. You know, for ductile materials, von Mises yield criteria is a quite suitable criteria. Gives us meaningful, correct solutions. Okay. For aluminum 6061, I do not remember the yield limit, but probably 72 is less than the yield limit. Refer to the handbook or the digital material library of Inventor, and then learn the threshold value, how much the yield limit. Or alternative, well, Inventor you see found the solution and listing here at the browser, von Mises stress. Yeah, well, von Mises stress only here at the parts. Well, you see head of the bolt is applying the holding gripping forces, while the stress at points in the vicinity of such a contact surface in the order of 70. But without referring to the material library, physical or digital, to be able to directly see whether there is a risk, well, ask Inventor to show factor of safety. Bring the cursor onto factor of safety option, right click the mouse and say activate. If you select activate option, then yes, Inventor will indicate the factor of safety. Well, I see factor of safety, the measure of the body is in the order of 50. It's quite safe. Well, smallest factor of safety in the order of 3, say that it is also acceptable factor of safety. If it were not, then either we will select as a solution for such a weakness a more strong material, not aluminum alloy but steel, for instance, or if it is allowed, well, by the users or decided by the designer, and or the size of the feature is increased to be able to, by which decrease the stress value. Okay, turn back to von Mises distribution part, right click activate, and then okay, well, here you can see the deformations. Well, Inventor using thin lines allows us to see the geometry of the body before loading, and well, the solid part represents the deformed form of the object, but do not say it is too much. To be able to make the deformations visible to naked eye, Inventor selects a certain zoom factor. Well, here, to be able to see the results, well, not amplified order, but actual order, select, for instance, if I select 5 times zoomed in, then you see, well, it seems as if it were well deeply deformed. Well, actual deformation option from this list, select. You see with naked eye it is not distinguishable. If you make zoom in, then can see the deformation. Be aware. Well, clicking on the prop button and indicating a point within the body or over the surface, at that indicated point can see numerically what is the von Mises stress. Well, this is a tool. Another tool, animation tool. If we clicked on animate, it is like a video film. Let me make zoom in to see the deformation with naked eye, and then yes, play. You see, while at the beginning force is 0 and then it is being applied and the body deforms. Okay. Another thing, well, clicking on report button can have a full report. First data for this problem, for this studying are sent to the host computer of Autodesk, and then over there the problem is solved and the results of the calculation graphically and numerically sent within a full report. Okay, dear students, for this video record, just about to say that's all, but okay, after performing the design calculation in Inventor and then clicked on finish analysis button, and then before closing this video record, now say have a look at the project folder. Well, Inventor created a subfolder and over there clicked on save. After saving the file within the folder, open the folder. Yes, you see this folder. I didn't create this folder. Inventor created that folder using the name of the solid model file. Okay, if we open this folder with double click, we find AIP. Okay, it is a folder. Open it, we find a nested one. It says finite element analysis. Open FEA folder, and then yes, these are the log files. Well, thanks to these files, Inventor, say the other person can, when the solid model file is open, can see the results of the calculations. This folder must be associative. Okay, send not only the solid model but also this log folder, this data folder, to the other person. If you simply send the solid model and forgot sending the calculation folder, the folder in which Inventor keeps the results of the calculation, and the other person cannot see the results, cannot see the calculated values, can only open the model. Okay, now I think, dear students, the things are clear, and then that's all in this video record. Well, say thank you.